Hi there. Welcome to Sejos. So that's my email in case you may have any question considering what I'm about to do or what I've done in the past. Okay. Now in this video I'll be working on a D operator question. It's one of the tutorial questions, and then let's see how I can do it. It's advisable that you try to do the question, and then this will be your solution, like to check if you are right. If you are wrong, you see where you got lost and all that. Okay, now we have here d squared plus 4d plus 5 operating on y, and then that is equals to 8t multiplied by sine t. Okay, so the question wants us to determine the general solution. Okay, we need to determine the general solution, and that is y is equals to y complementary plus y particular. So that is, this is the complementary solution and this is the particular solution. Okay, and then in this instance I'm going to start with determining our complementary solution. Okay, so with the complementary solution, our right hand side is equal to 0, so that means we're gonna have d squared plus 4d plus 5 operating on y is equal to 0. Okay, and then we need to factorize this thing here, so I'm gonna use quadratic formula. Okay, so we're gonna have d is equals to minus 4 plus or minus the square root of 4 squared is equals to 16 minus 4 AC, so minus 4 by 5 is equals to 20. Okay, and all this is divided by 2. Okay, and then when we work this thing out, we find that d is equals to minus 2 plus or minus I. Okay, so that is d is equals to minus 2 plus I, or minus 2 minus I. Okay, so that means we can factorize this as being d plus 2 minus I multiplied by d plus 2 plus I. Okay, and then operates on yc is equals to 0. Note that I just took this thing to the left hand side, okay, to give me this thing here. Okay, and now we need to write our solution. So y complementary is giving us e to the power of our real part opposite the sign of the real part in of this vector here. So we're gonna have minus 2t multiplied by a constant p cos t, because the coefficient of I is 1, so it's cos 1t plus q sine of t. Okay, so this is our complementary solution. Okay, now we need to determine our particular solution of this question here, which is going to be very long. Okay, so let me just copy down the question. So we have d squared plus 4d plus 5 operating on y is equals to 8t sine t. Okay, now we need to determine our particular solution. Okay, to do that, this is what we have to do. Okay, so yp is equals to 8t sine of t divided by d squared plus 4d plus 5. Okay, Now, taking note of this, we are aware that sine of t is the same as the imaginary part of e to the power of it. Okay, so we can represent sine by e to the power of it. Doing that, we're gonna have 8t, the imaginary part of e to the power of it, divided by d squared plus 4d plus 5. Okay, in this stage we can apply shift lemma, which tells us that we need to take this imaginary sign here and then substitute d by d plus I. Okay, so we're gonna have the imaginary part of e to the power of it divided by, where there is d, we substitute it by d plus I. So we're gonna have d plus I all squared plus 4d plus 4d plus 4I plus 5, and that is multiplied by 8t. Okay, now let's try to work out the denominator. We're gonna have the imaginary part of e to the it divided by d squared plus 2id minus 1, right? So we're gonna have plus 4 plus 4I plus 4 plus 4d. Okay, should be 4d here, sorry. Okay, note that the minus 1 here, this 4 comes from 5 minus 1 of I multiplied by I. Okay, and everything is multiplied by 8t. Okay, now we need to write this fraction here in the form 1 over z plus 1. Okay, so we're going to do that by factoring out our constant, which is 4i plus 4, and then that will be equals to the imaginary part of e to the power of it divided by, if we are to factor out 4 here, we're gonna have I plus 1. Okay, and then we multiply that by d squared plus 2id plus 4d, and everything here is divided by 4i plus 4. Okay, and then this is added to 1, everything is multiplied by 8t. Okay, now we can write this thing here in the form, like if you are to consider z, you can write it in this form. You can write it as being 1 minus z plus z squared and so on. Okay, doing that, and one other thing is that we can cancel out this 4 and down, and then this 8 to have 2t here. Okay, so we're gonna have yp being equals to the imaginary part of e to the power of it divided by I plus 1 after dividing 4 and then this 8 here. So we're gonna have this being 1. Okay, we're gonna have 1 and then 1 minus d squared plus 2id plus 4d, and this is divided by 4 into 1 plus into 1 plus I. Okay, let me write what I'm saying, okay, so that you not get confused. 4 into 1 plus I, and then note that if we had to take the squared of everything here, we're gonna get d squared, and we see that the power of t, t can only be differentiated once. So anything that is differentiated twice is going to give us 0. So we're going to stop here and then multiply everything here by 2t. Okay, so we're going to multiply this bracket in here by 2t, and that will give us the imaginary part of e to the power of it divided by I plus 1, and then that is multiplied by 2t minus, and then in bracket we're gonna have 4i. Okay, so we're gonna have 4i. I want you to take note of that because I don't want to write it, so that I will just cancel out in the step. So listen very attentively. When we were to differentiate this t to t according to this time here, we're gonna get 4i. Okay, so let me just write it here, 4i. Okay, and then when we differentiate it here, we're gonna get 8. We're gonna get 8 only, so we're gonna get positive 8. And then if we are to divide this thing here by 4, we see that we're gonna get I plus 4 divided by 8, 8 divided by 4, we're gonna get 2. Okay, and then everything here is divided by 1 plus I. Okay, now we are in this stage. So what we can do is to take the conjugate of 1 plus I here, and then the conjugate of 1 plus I here, to be able to, so that we don't have complex numbers in the denominator. Okay, and that is what I'm gonna do in this next page. Okay, so I'm saying that I wanna take the conjugate of 1 plus I, right? So that will give me okay, so remember we're doing yp, right? So that will give me the imaginary part of taking the conjugate of this, we're gonna get in the numerator 1 minus I divided by, and then taking the conjugate of this thing here, we're gonna get 2, and this is multiplied by e to the power of it, and then everything here is multiplied by 2t minus I plus 2 multiplied by 1 minus I. We're also taking the conjugate here, so this is divided by 2. Okay, so we are in this stage. We're in this stage. So when we work this out, we are aware that we're gonna get yp to be equals to we're gonna get the imaginary part of, we're gonna get imaginary part of 1 over 2 minus I over 2 e to the power of it, and then we're gonna have 2t minus, okay, when we work this out, we're gonna get I minus 1, and then by 2 we're gonna get 3, and then multiply by minus 2. So when we work this thing out here in the numerator, we're gonna get minus 3 minus I, all divided by 2. Okay, note that you must take note of these things that I'm not quite explaining very good, but note that it's a simple thing, simple multiplication. So okay, going forth, we're gonna have imaginary part of, let me factor out 1/2 here, and then in here I'm gonna get 1 minus I, okay, and then everything is multiplied by e to the power of it, and then that is multiplied by 2t, okay, and then we subtract note that we're gonna say 1/2 1 minus I multiplied by e to the power of it, and this is multiplied by this thing here, of which is 3 minus I, all divided by 2, okay. Yeah, so we are in this case here. So what we have to do now is this. I have to say this is equals to. Now we're going to write e to the power of 2 in terms of sine and cosine, and then one other thing that we can take note of is that we have 2 in the denominator and 2 in the numerator, meaning that these 2 is gonna cancel out, and then here okay, we'll cross the bridge when we get here. Okay, so we're gonna have the imaginary part of so I'm gonna multiply this t by this thing here, so I'm gonna get t minus I, and then gonna write e to the power of it in terms of sine and cosine, so and this is multiplied by cos of t plus I sine of t, okay, and then we're gonna subtract 1/4 into, note that I'm saying 1/4 because I'm gonna multiply this 2 here by this 2, so you're gonna give me 1/4, and then okay, we're gonna have again to work out this this bracket here, so we're gonna have 1 minus I multiplied by 3 minus I. Okay, let me just write e to the power of it so that I can work out this bracket multiplication in the next step. Okay, so we have this being equals to, that is being equals to, okay, it's kind of dark here, so let me just turn on the light. Okay, yeah, okay, so where was I was doing this equals to the imaginary part of okay, so let's first multiply this thing out here so that we know what to expect. So 1 multiplied by 3, we're gonna get 3, and then 1 multiplied by minus I, we're gonna get minus I. 1 multiplied by 3, minus I multiplied by 3, we're gonna get minus 3I, and then minus I multiplied by minus I, we're gonna get minus 1. Okay, so we have something like minus 4I minus 2, plus 2. Okay, so that this can be written as t minus it. Okay, I forgot the t here, there is a t here. T minus it cos of t plus I sine of t. Okay, and then we subtract 1/4 into 3 minus 1, we get 2 minus 4I, and this thing here is multiplied by cos of t plus I sine of t. Okay, sorry about this. Okay, but it's cos of t plus sine of t. Okay, so we're gonna get the imaginary part of okay, let me just multiply out. So okay, so we're gonna have t cos t, and then plus it sine t minus IT cos t plus t sine t. Okay, note that everything here is because of this multiplication here. Okay, now allow me to write this ones here under here, under this one. Okay, so note that we can factor out 2 here. We can factor out 2 to have 1 over 2, and then in here we're gonna have 1, okay, and then 2. I hope you're aware of what I'm doing. This is 2, this is 2 here, and this is 1 when we factor out 2, and this fraction here is 1 over 2. Okay, so we're gonna have 1 over 2, and then we're gonna have multiply by cos of t. 1 multiplied by cos of t is cos of t. 1 multiplied by I sine of t, we're gonna have plus I sine of t. Okay, and then I over 2, 2i multiplied by cos of t, we're gonna get minus 2i cos of t. Okay, and then we're gonna have plus 2 sine of t. Okay, so let's take our imaginary parts here. Note that we have the imaginary here. This is imaginary. Multiplying this, we're gonna have this as being imaginary, and also this is imaginary. Okay, so we have 1 2 3 4. Okay, so it's gonna be sorry, when we are writing imaginary parts we don't put I. Okay, so let it be t sine t, and then minus t cos t, and then coming here, note that we are multiplying what's in the bracket by half, so we're gonna have minus 1 over 2 sine t, and then plus it's plus because we have minus here multiplied by this minus, so it's gonna be plus cos of t. Note that these 2's here cancel out, so we have something like this. Okay, and then we can further simplify this to be cos t multiplied by 1 minus t. Okay, and then plus sine t multiplied by t minus 1 over 2. Okay, so this is our particular solution. Okay, now to determine the general solution as required, you're just gonna add this to the complementary solution that we found earlier on here, because you're just gonna do this, so that will be your general solution for this question here. Okay, okay, that was it for this question, and then we have another video. Check out another video on the operators, where I'll be using cosine. I'll be working the problem using cosine, which is the real part of e to the power of it. Thank you for watching. Enjoy whatever you're doing and your studies. Thank you.